Today we will discuss about problem related to graph from one-dimensional motion. This channel provides you the physics lecture for class 11, 12, NEET and JEE in English version as well as in Bengali version. To see the unit-wise video lecture, go to the playlist of this channel. So let's start. Here I will discuss the problem related to graph type by type so that you can understand how I solve the problem. You have to mind it that you have to learn the process how I solve this problem related to graphs. Here type number 1. Type number 1. Type 1. What is type 1? You have to know which graph is not possible. Which graph is not possible. Which graph is not possible? Type number 1. There is 3 types of graph. That means one is distance versus time graph, and another number 2 is displacement versus time graph, and another is number 3 is here. Suppose here is number 3, and number 3 is the velocity time graph. That means velocity or speed time graph, velocity versus time graph. This is the 3 types of graph. Now you have to know which graph is not possible. Suppose number 1. Suppose this is the, here the time is t and here is distance is along this direction. Here is distance. So if I draw the graph like this, then it will be, here is t, then it will be, what will be the speed? Here speed will be, v will be s by t. Here see that this straight line is parallel to this axis. So these are parallel. So it time taken to reach this point is 0. So at instant of time, that means to reach this point from here to here, it takes time 0. So it will be s by 0. That means infinite. So it is not possible. So a particle have infinite velocity is not possible. So this graph is not possible. So here you see that this line is parallel to the axis of this. So this particle reach this point from here to this point at a time of 0. So the velocity of this particle is infinite. So infinite velocity is not possible. So this graph is not possible. So number 2. If I draw like this, so this is time t and here is distance is s. If I draw the graph like this, then what happened? Here when time is increasing, the distance is decreasing. This is not possible. When time is increasing, then distance will decreasing here. distance is decreasing. So it's not possible because distance cannot be diminished, it must be increased. So here this is not possible, this is not possible. So here is the velocity is infinite for that cause this graph is not possible. Here the distance is decreasing with increasing time, so it is not possible. So these two graph is not possible. Another is, suppose I draw the, here is suppose t and here is distance s, and if I draw like this, then what happened? Then it happened that suppose this is the point. At instant of time, at an instant of one time, the particle has two positions. That means here is S1, here is S2. So at a time, particle has only one position. They have no two position. They cannot possess two position at an instant of time. So this is not possible. So this graph is not possible because at the same time this particle possess two position. This is not possible. So this graph is not possible. So here I have discussed that this which graph is not possible at distance versus time graph. This graph is not possible for the infinite velocity of a particle. This graph is not possible due to the distance is decreasing for increasing time. And here is this graph is not possible because at the same time this particle possesses two positions. This is not possible. So this three graph is not possible. Number 2, what is the displacement versus time graph? Suppose this is a time and here is displacement. Displacement is a vector quantity. So if I draw like this, then the velocity will be the s by t. Here t is 0, so it will be infinite. So this graph is not possible because particle cannot possess infinite velocity. Number 2. So this graph is not possible. Number 2, if I draw the displacement versus t graph like this. This is not possible because at every instant of time it has two position. Every instant of time it has two position. So at the same time particle cannot possess two position. So this graph is not possible. So this is the 3 case here. Here is this 2 case. And now the velocity time graph. Here is, suppose there is time t and here is velocity. So if I draw like this, then you see here this is the any instant of time. So at the same instant of time this particle has two velocity. This is impossible. So this graph is not possible because at the instant of time, at the same time this particle has two velocity. This is not possible. Number 2, if I draw the velocity time graph in this way, here you see that all the time it has two velocity. At the instant of time it has two velocity. Suppose this time t1 it has 2 velocity, this time t2 it has 2 velocity, and time t3 it has 2 velocity. So this graph is not possible, because at the same time particle has only one velocity. This is the type number 1, which graph is not possible. Now some problem I will give you. You have to answer it related to which graph is not possible. Suppose number 1 there is 4 graph. Suppose this is a VT. This graph is like that. Another graph is, suppose this is T and this is V. If the graph is like that, like this, another graph is, suppose another graph is V and T. It looks like, suppose this is the another graph, this is another graph, and another is, suppose T here is V. If this curve like this, then you have to find out which graph is not possible. Which graph is not possible. Here the velocity and time change. Here is, it has a specific acceleration, there is a specific acceleration, so it is possible. So it also possible, it is constant velocity, after some time it will a constant velocity. But here this is possible, and here at the same time, that means at t equals to 0, this is t equals to 0, it has two velocity. So it is not possible, because particle has only one velocity at a time. So this is not possible. Here is a deceleration, here is acceleration, this is possible. So this graph is not possible. Number 2, if I draw the velocity time graph like this, suppose this is the one type graph. If I draw another velocity time graph like this, suppose this is another graph. If I draw another velocity time graph like this, suppose this is the another velocity time graph. If I draw velocity time graph like this, then what happens? Suppose this is the another velocity type graph. Then you have to find out which graph is not possible. Here this is a constant velocity, here is acceleration, there is deceleration, here is constant velocity, so it is possible. Here is constant velocity, then it increase, that means it has a acceleration, steep, very large acceleration, then it deceleration, that it constant. This is possible because this velocity will increase with time, then decreases. Here you see that at an instant of time, every instant of time, it has two velocity, which is not possible. So this graph is not possible. So this is the number 2 problem. Suppose there are number 3. Another problem, suppose number 3. If I draw the time versus, suppose this is the displacement or distance, here is time. If I draw the graph like this is another type of graph. Number 2, if I draw, here is displacement, here is time. You notice this axis is time axis and this axis is displacement axis, okay? And another is, suppose like this, and another curve is there is S and there is T. If another curve is like this and another curve is like this, but you have to find out which curve is not possible. Here you have to find out which curve is not possible. Here you see that the time is increasing. After increasing, it reaches maximum, then decreasing. Time always, here is time first increasing, then decreasing. Time always increase. Time always increase. It do not decrease. Here is that time is decreasing. Here is time is decreasing. So it is not possible because time cannot decrease. It always increasing. So here you see that the time is decreasing. So it is not possible. So this graph is not possible. Here you see that the increasing of time, the displacement increase, so it is okay. Here is the time is at an instant of time, that means the velocity is s by t. So this particle takes time t equals to 0 to reach point B from A. So the velocity will be s by 0, that means infinite. So this infinite, so particle cannot possess infinite velocity. So this curve is not possible. Here the distance and time is proportional to each other, so it is a straight line, so this is okay. So this curve and this curve is not possible. So I have discussed the type number 1, which graph is not possible. If you understand this portion, then you will be able to answer any type of question related to which graph is not possible. Now, type number 2. Type number 2. You have to draw graph for specific condition. You have to draw graph for specific condition. That is number 2, types number 2. So some specific conditions are given to you, then you have to draw the graph or ST, VT or AT. Suppose number 1. Number 1 is an object is dropped from rest. Then if dropped from rest and air resistance is neglecting. So you have to find out VT graph, V versus T graph. So if an object is dropped from rest, so this is a ground, and suppose a particle is here, the height is suppose s, suppose this is the height is s. So drop from rest, that means the velocity here is 0. So here the velocity of here will be u plus a t, that means it will be 0 plus gt, then v equals to gt, and v is proportional to t. So it will be straight line. It will be straight line with positive slope. Here is g is positive, so straight line with positive slope. So what is the velocity time graph? Here is velocity, here is time t. t. So it will be straight line if t is 0, v is 0. So when time is 0, the velocity will be 0. So it looks like this. This is the velocity time graph when a object dropped from rest. Here number 2. Suppose a ball is thrown vertically upward. Then you have to draw V versus T graph if the air resistance is neglecting. Then suppose this is the ground. The velocity of this ground at ground is V. At any instant of time, suppose this is the height and there is velocity is V, then V equals to U minus gt. So V equals to, if this is 0, that means V equals to g. Suppose the at highest point, if this is 0, that means it will be minus gt. So it will be V proportional to t. So it is straight line. It will be a straight line with negative slope. Here is negatives. So it is with negative slope. So the VT graph will be so at t equals to 0, the velocity will be maximum. Suppose this is V. So after some time, when time is increasing, the velocity will be decreasing. At maximum time, the velocity will be 0 when it will reach the maximum point. So it is a negative slope. So the velocity time graph from when the ball is thrown vertically upward looks like this. This is the number 3 problem. Now number 4. If number 3, suppose a ball is dropped vertically from a height d, above the ground, and it hits the ground, and bounce back vertically upward to a height d by 2. Here is number 3. A ball is dropped vertically from a height d above the ground. It hits the ground and bounce back vertically upward to a height d by 2. So this is the ground, this is a ground. First a particle is dropped from height d. Then at this point the velocity is 0. When this particle reach at the ground, the velocity will be v equals to gt. Then if I relate with height and velocity, then it lies that v square equals to u square minus 2as, that is plus 2as. If v equals to, this is 0, so it will be 2gs. Here is s is height, so it looks like this looks like v square equals to 2g d. So here is v square is proportional to d. So if I draw the distance, that means height versus velocity. Height versus velocity. Here is height and here is velocity. If I draw the height versus velocity graph, then it looks like parabola. It looks like parabola. This is a equation of parabola. So when a particle is dropped vertically downward from a height d, then when this reach the ground, after reaching the ground, it bounce back and reach d by 2 height. So at this condition, the velocity suppose is v1 equals to will be ev, so it will be egt. At a distance of d by 2, here velocity will be 0. So if I take the upward direction is positive, if I take the upward direction is positive, that means this is a positive value. So this is the velocity of this condition is in negative and this condition is positive. So if I take upward direction is positive, then the graph is in this condition v1 will be positive. So suppose this is d by 2 and here is d. The height is d by 2 and d by t, and the velocity, suppose this is e v1, this is v1 means e into v, and here is negative velocity will be v. There is maximum velocity, suppose v, because v is greater than v1, so this is the elastic constant. So it looks like parabola and it looks like parabola. So this is the graph for this condition and this is the graph for this condition. So do you understand? So when a particle is dropped from a height d, then the velocity at ground is v equals to gt, and the nature of the velocity versus height graph will be parabola because v square is proportional to height. So when if I take the velocity in this direction is positive, then in this direction is negative. So in this condition it will like this condition, the velocity height graph looks like this, and when this particle go upward, vertically upward at a distance d by 2, this direction will be taken as a positive, is taken to be a positive. So this is a positive velocity, then it decreases at 0. So this is the velocity height graph for this condition. It is a very important problem. Now another problem is number 4. Another problem is number 4. 4 is a ball. Number 4, a ball is thrown vertically upward. If air resistance is not neglecting, then what? Neglecting. Then you have to find out V versus T graph. So there is two condition. When a ball is, this is ground, so this ball is moving to the highest point and reach the same point. So there is two conditions. This is upward direction, it is downward direction. So here is resistance, air resistance is there for the upward condition. Here is, suppose this is upward condition and another is downward condition. I will discuss all the case. What is the downward condition? When upward condition, this is the, suppose this is a particle. If this is a air resistance will be along this direction and it move, the mg is along this direction and the force direction of this acceleration will be along this direction. If I use the formula of Newton's law, that means total mass into acceleration must be equals to the mg plus fa, and both will be negative because both will be negative because this is a direction opposite to these two force. So ma equals to mg plus fa. That means at this condition the acceleration will be minus g plus fa by m. Here fa is the air resistance. For this condition the slope is negative. When the particle go upward, then the rear resistance is acting downward. So if I calculate the resultant acceleration in this condition, it looks like this. So here you see that the acceleration is negative. So the velocity time graph, the slope must be negative. Slope must be negative. So if I draw, there is velocity time graph, then it looks like that. This is the condition number 1. So at time t equals to 0, it has a maximum velocity. After reaching maximum time, that means it's reaching maximum height, then the velocity will be 0. Here velocity will be 0. So this is the condition in this condition. Now when the particle comes down, then what happened? Here the air resistance along this direction and mg along this direction. So and at this condition the acceleration is along this direction. So if I use the Newton's law of motion, total mass into acceleration equals to the resultant force. What is the resultant force? Equal to mg minus fa. So it's the acceleration will be g minus f by a, g will be fa divided by m. So it a positive slope. This graph will be a positive slope, but it slope will be, here is the value is less, here is value is greater, because here suppose this is a1, this is a2. So a1 is greater than a2. So slope of this curve and slope of this curve, what is the slope? So slope of number 1 must be greater than slope of curve number 2, because at this condition the acceleration is less and here is acceleration is greater. So in this condition it will be along this direction. This will be negative, this is the positive slope, here is positive slope, and here is negative slope. negative slope. So it is a upward direction. Here is a downward direction. This is the velocity time graph when air resistance is considering. This is the graph number type number 2. This draw graph for specific condition number 3, type number 3. What is the type number 3? Type 3. What is the type 3? Type 3 is choose the perfect portion of charge. Choose the perfect portion of the graph for specific condition. This is the specific condition. This is the one type of problem. If I draw, here is suppose xt graph. Here is t and here is x. That means displacement. If I draw like this, suppose this is 1 and this is 1, this is 1, this is 1. If I draw the curve of xt of a particle A to B, here is C, here is D, here is E. You have to find out the portion. Find out the portion of the graph where no force is acting. So here is a xt versus x versus t graph. This is the graph of a particle. You have to find out which portion of this graph there is no force acting on a particle. So there is a 4 portion of this graph. One is A to B and C to D. Both are similar. Here is acceleration, that means velocity is displacement increasing and displacement is decreasing. And another is B to C and D to E. This is similar. So at A to B and C to D, slope is constant. Here is slope is constant. If slope is constant, that means x by t is constant. If x by t is constant, that means velocity is constant. If velocity is constant, that means acceleration is 0. If there is no change in velocity, then acceleration will be 0. That means acting force equals to m into a. That means acting force is 0. So in this portion and in this portion, acting force will be 0. Now what is happened at B to C and D to E? You see that the slope, here is slope is decreasing, here is slope is increasing, here is slope is increasing. That means slope is not constant. Here is slope does not constant. Slope is not constant. That means increasing or decreasing. So if slope is increasing or decreasing, that means x by t have a positive value, positive or negative value, or negative. So it has positive or negative value, that means will be changeable. That means it is changeable. And if v is changeable, then there is a acceleration. That means it has a value of plus or minus. So it has a force because F equals to ma. If there is a acceleration, though at this condition there will be a force. You have to find out which portion of this graph there is no force acting. So this is the condition. This portion, that means A to B and C to D, this portion there is no force acting on a particle. But at this portion there is a force, at this portion there is a force acting on this particle. Now number 2, this is number 1. Then I will discuss number 2. If I draw number 2 question, if I draw a, this is x t graph, that is x, here is t. If I draw this graph along this direction, if I draw another graph is t, here is x, here is x. If x is given by this graph and another graph is t, here is x. If this curve is looks like that and another curve is, here is t, here is x. If this curve is like this, so here you have to find where the particle has zero acceleration. In which graph, particle have zero acceleration. In which graph the particle has zero acceleration. Here you have to calculate the zero acceleration. So in this graph, slope is, here is, in this condition slope is decreasing or increasing. That means slope has a value. Slope is increasing or decreasing, not constant. If slope is a value, then it will be x by t will be a increasing or decreasing. So v is increasing or decreasing, so there will be a acceleration. So in this condition there will be a acceleration, there will be a specific acceleration. So this is have a acceleration. But at this condition slope is constant. If slope is constant, that means x by t is constant. So v is constant. If v is constant, that means acceleration is 0. So at this condition acceleration is 0. Here you see that in this condition, this is, here is slope is increasing, here is slope is decreasing. So in this condition there is a acceleration. And here you see that at this condition you see that there is the t, x is constant, so there is no slope, that means velocity is 0, so at this point the acceleration is 0. For this graph shows that the particle has the acceleration of 0. Here is velocity is 0, so there is no option for acceleration. So that means it's a rest condition. This is a rest condition. This particle is at rest. This is the number 2 problem. Suppose there are one types of problem. So if I discuss another problem, then what happened? Number 3. If I draw the graph like this, if I draw the velocity time graph, like this, and another is, suppose this is velocity time graph, this looks like this, and another is suppose t and v. If I draw the velocity time graph looks like this, and another graph is t, here is v. If I draw the velocity time graph looks like this. So here you have to find out the uniform, which graph shows the uniform acceleration. uniform acceleration. Which graph has a uniform acceleration? You have to find it. Here you see that the slope is increasing. If slope is increasing, so acceleration will be increasing. Here is slope is increasing. If slope is increasing, so velocity by time will be increasing. So acceleration will be increasing. So it is not the uniform acceleration. It is not uniform acceleration. Here acceleration is increasing. Here you see the slope is decreasing. Here is slope is decreasing. If slope is decreasing, that means v by t is decreasing. If v by t is decreasing, that means acceleration is decreasing. Here is acceleration is decreasing. Now in this case, here is slope is constant. Here is slope is constant. So v by t is constant. So v by t constant, that means he is constant. So it is a uniform acceleration. That means a equals to constant. That means it is a uniform acceleration. So this graph shows the uniform acceleration. Here this is uniform, the another. So for whole journey it is not a uniform acceleration. Here is acceleration is constant. Here is acceleration another value. It has the acceleration of specific condition. That means suppose a value of a1, here will be the acceleration is a2. So whole journey in this condition there is two uniform acceleration. While the acceleration there is a deceleration. So in this condition this graph shows the uniform acceleration. So this is the type 3. Now I will discuss type. That means if I take another problem number 4. If I take another problem number 4 of type 3, number 4. If I draw the xt graph like this. If I draw one graph is along this direction, here is x, here is x and t. I draw this in this condition, here t, here is x. If I draw this is the one types of graph, and another is suppose I draw a graph like this. So you have to find a uniform motion. Which graph shows uniform motion? Which graph shows uniform motion? Uniform motion, that means velocity must be constant. Uniform motion, that means velocity must be constant. When velocity is constant, then the motion is called uniform motion. Here is velocity is not it. This is a rest condition. Time is given not. This is a particle of rest. Here is v equals to 0. Here is the slope is increasing. Here is slope is increasing. So x by t is increasing. So v is increasing. So here is v is increasing. Here the slope is slope is decreasing. So here is slope is decreasing. So if slope is decreasing, so velocity will be decreasing. So here velocity is decreasing. Here is slope is constant. So v by x by t is constant. So v equals to constant. So it is a uniform motion. uniform motion. So this graph shows the uniform motion. Now if I take another problem, number 5. If I take another problem, this is number 5. If I draw VT graph like this is a VT graph. If I draw like this VT graph, now if I draw another VT graph is like this. Suppose this is a VT graph. Now another VT graph is like this. This is a VT graph. Another VT graph is like this. Suppose this is along this direction. Now another VT graph is look like this. This is a VT graph. You have to find out which graph represent realistic motion of a particle, of a bus or car, realistic motion of a body. That means realistic motion, that means motion of a car, motion of a motorbike, motion of a bus. You have to which graph represent the realistic motion of a body, that means realistic motion of a car or of a bus in your society. So this graph, suppose this is a time. Here the at time, suppose this is t1 at t1 this particle has 3 velocity. So this particle has 3 velocity is not possible. So this graph is not possible. Here you see that the time velocity is increasing, say then decreasing, then increasing and then decreasing. When car is moving on a road, during this journey he accelerates the car. After some time he deaccelerates his car, then again he accelerates this car. That means he can, here you see that the velocity will increasing, then decreasing, then increasing, then decreasing. So this is the realistic condition for motion. This is the realistic condition of our motion of a body, of a bus, of a car. When car is moving on a road, so for whole journey it cannot hold a constant velocity. So during this journey he decrease their velocity or decrease her velocity or increase her velocity. So this is the graph which shows the realistic motion of a body. Here you see that suppose this is a time. So this graph is not possible. Here is 3 velocity is at a same time. So this graph is not possible. This curve is not possible. So this is the perfect curve or graph which shows the realistic motion of a body. Now number 4. Here I will discuss number 4 types of question. Type number 4. Number 4, transformation of curve. Number 4 is transformation of curve or graph. Transformation of graph. Suppose number 1. Suppose this is the time and this is acceleration. If I draw this like this, this is t1 and this is t2. You have to find out, here is acceleration versus time graph. You have to find out the velocity versus time graph. So what is the velocity of time graph? If the acceleration is change according to this graph. So up to T1, T2. Here 0 to T1 the acceleration is constant. That means acceleration is constant. Acceleration constant, Vt by equals to constant. V equals to V is proportional to T. So this is will be straight line. This is will be a straight line. From it T is 0, V will be 0. So it will be a straight line of a slope, perfect slope. Now from T1 to T0 the acceleration is 0. If acceleration 0, V by T equals to 0. So if I take the ds by dt, that means dv by dt equals to 0. That means dv equals to 0. If I integrate, v equals to constant. So T1 to T2 v will be constant. Now at this condition it looks like the same condition, so it will be along this direction. So the slope and here is, suppose this is theta and this is must be theta, because this is same. If there is here, then the slope will be increasing, then slope will be here. That means at this condition slope will be increasing. This is the first condition. If this value acceleration and this value acceleration is same, then these two angle must be same. If this is a condition number 1, if there is this acceleration is along the direction, that acceleration will be increasing. So if acceleration increasing, then the slope of this curve will be along this direction, that means slope will be increasing. So this is the transformation of one type graph. Number 2. Here I discuss how to transform a curve. You have to learn the process. Okay, now suppose there is another transformation. Suppose this is a curve of S versus T graph, S versus T graph, and it looks like this. You have to transform it. Here is displacement versus time graph. You have to transform it velocity versus time graph. Here is the maximum point, here is the maximum point, and here is the another point. So here you see that the slope will be decreasing. If slope is decreasing, so slope is decreasing. So slope is decreasing, that means here is velocity S by T is decreasing, that means velocity is decreasing. If velocity is decreasing, so it is a negative slope, it must be negative slope, so it looks like this. So if here you see that this slope is decreasing, here is theta, here is theta, here is theta, theta will be decreasing. Here is theta is decreasing, that means slope is decreasing, and if slope is decreasing, that means velocity will be decreasing. So at a highest point the velocity is 0. Now in this condition the slope is increasing and is a negative direction, increasing and a negative direction, so it looks like that. The velocity time graph will be looks like this, because here is slope is decreasing, that's why the velocity will be decreasing. Here is slope is increasing, so velocity will be increasing but in negative direction. This is the graph, that is transformation of graph, that means type number 4. There are type number 5. So you have learned how to transform a graph from one types of graph to another types of graph. Now number 5. What is the number 5 problem? Types number 5, you have to calculation of various physical quantity from graph, physical quantity from graph. Suppose this is a displacement, this is time. This is a displacement, this is a time. If the graph of particle A and there is a graph of particle B, if there is a graph of B, so if this angle is 45 degree and this angle is 60 degree, you have to find out the velocity of A and velocity of B. That means velocity of A will be tan 45 degree and velocity of B will be tan 60 degree, because slope of a ST graph gives the velocity of a particle. So it will be 1 and it will be √3. You have to ratio of this particle, that means 1 by √3, that means it will be 1:√3. Number 1. Number 2, if I draw the SVT graph, that means ST graph. If I ST graph, this looks like this. If the ST graph looks like that, this is the point A. Suppose this is a point A, that's the t equals to 1 second, and another point is B. This is the B point at t equals to 2 seconds. So if the slope, this is the slope, if I take slope of A point, this is suppose 45 degree, and if I draw this slope at B, the angle is 60 degree. Then you have to calculate the acceleration. That means velocity at A it will be tan 45 degree, because it is a ST graph. So ST graph gives the slope of ST graph gives the velocity at that point. So at point B it will be tan 60 degree. Times taken to reach the particle at B from A is 1 second. Here is 2 minus 1, that means 1 second. So acceleration will be the change in velocity divided by time. So acceleration will be, here is 1, here is √3, that means √3 minus 1 divided by 1, that means √3 minus 1 meter per second square. This is the calculation of this, how to calculate acceleration of from a graph. Now another problem. Suppose this is a T and here is V. V is meter per second and here is second. So if I draw, suppose this is 10 and this is minus 10. This is 5, this is 10, this is 15, here is 20. If this particle, suppose it like this, after this if the graph of velocity is changing according to this graph, then first you have to calculate the displacement, that means distance covered by particle in 20 seconds. Number 2, calculate the displacement covered by the particle in 20 seconds. Now you have to find out the average speed. Now you have to find out average velocity velocity. How to find out the distance? Distance equals to total area of this curve. So total area of this curve you have to calculate it. So distance equals to total area of the curve. So if the velocity time graph, there is a velocity time graph, so the area of the velocity time graph gives the distance of this area of the velocity time graph gives the distance. So if you have to calculate distance, then you have to calculate the area of this portion. Here is this portion, this portion, this portion, and this portion. It will be area of this point half into 5 into 10 plus it will be 5 into 10 plus it will be half into 5 into 10 plus this will be half into 5 into 10. So it will be, this is 5 and this is 5 and this is 5. So it will be for 25, 50, it will be 25, it will be 25. So this will be 75 plus 50, that means 125 meter. This is the total distance. Now you have to calculate displacement. What is the displacement? When displacement is a vector quantity. So in this portion, the area of this portion will be negative. So it will be the same, that means 5 into 10, because this is the area of this portion, plus area of this portion equals to 5 into 10, 5 into 10 plus area of this portion will be half into 5 into 10, and here will be negative because this portion area is negative and displacement is a vector quantity. So you have to take the negative quantity. So it will be half into 5 into 10. Though this portion will be cancelled out. So it will be 5, that means 25 plus 50. So it will be 75 meter. So displacement is 75 meter and here is distance is 125. So average speed equals to distance divided by total time. So distance is 125 and time is 20 seconds. So this is the meter per second. This is the average speed, and average velocity will be total displacement divided by time. So it will be, displacement is 75 divided by 20, that means it will be 75 by 20 meter per second. This is the time number 1. If you want to calculate the acceleration in this portion, there is acceleration, in this portion there is a deceleration. The acceleration will be the slope of this curve, that means 10 divided by 5, that means 2 meter per second square. This is the problem related to graph.